It's not in the interval, like it's not greater than pi or less than 2 pi. So would that be, that's like what the answer has to be in. So would I just put undefined for that? Or?
Okay. Oh, no answer. Now let's look at it and see. You said 7C?
Yeah.
So let's all take a look at this now and refresh our memories. What makes these problems tricky is exactly what Sid said. You have got to pay attention to where your angle can be, where your answer can be. Okay? So here we go. First of all, where is the cosine negative? So think about your coordinate plane, think about all of these places. Where is the cosine negative?
Quadrants 3 and 4.
Cosine is which letter?
X.
X. Where is X negative?
2, 3.
Here or here, right? So whatever answers I come up with, this would be the only place the cosine could be negative. However, given that, keeping in mind this is pi and this is 2 pi, this isn't going to count, is it? That's not in the right area. Would you agree with that? So now I got to find the angle whose cosine is negative 0.85. Now, Sydney, I have an idea of what might be causing you trouble. Do you remember back when we were first doing these a month and a half ago, that I said sometimes it's wisest not to put that negative in?
Oh.
So I'm going to go ahead and set my calculator in radians, because that tells me I'm in radians. And I'm going to second cosine 0.85. I'm not going to put the negative in, because all I want to know is the size of that reference angle right there. Okay? So I'm going to do 0.8 for second cosine 0.85, and I get I'll just round it off, 0.55. So that angle is 0.55. Now, I need the angle, the whole angle, the big angle, this one right here, right? So how will I find that? Pi plus, yep. So I'm just going to take that guy plus pi, and I get 3.70. I got 3.696 radians. Now, I want to make sure we're all clear on this, okay, you guys? If you second cosine negative 0.85, if you just go ahead and put the negative in, you do not get the reference angle. This is called the reference angle. You get this angle right here. This is the angle that you get. It's 2.587. Now, if that's how you started, that's okay, but then you'd have to figure out what this is and then add it to pi to get your answer. So I think it's just easier not to mess with the negative.
Okay.
I never mess with the negative. With tangent and sine, it really isn't an issue, but cosine it is every time, so I just don't do it.
Thank you.
Great question. All right, who else found something on this sheet that you weren't sure about? Yes, Sabrina.
Could you do 4B?
4B. Now, 4B is, oh, I left off a symbol in there. It's kind of the same thing. Only this time, Sabrina, we are going all the way around our circle. So we could be looking at reference triangles everywhere, all the way around the revolution. So sine x equals root 3 over 2. Just solving my equation like regular. And this should be a no calculator problem. Yes, it is. Because what's special about root 3 over 2? Well, that's one of my triangles, isn't it? So if I've memorized the unit circle, great. If I haven't, I got a triangle that has a sine of root 3 over 2. So how big is this angle right here? 60, and I'm supposed to be in radians though, so 60 is pi over 3, a third of 180. So my reference angle is pi over 3. One of your answers, Sabrina, is pi over 3. Are you keeping up here? Now, where's the other answer going to be? Where else could the sign be positive?
I think right beneath. No.
Remember, sine is which letter? Y. Where's y positive? Up. So we got this one is pi over 3, and we got this one is pi over 3. So what's our other angle? Remember, you're measuring it in standard position. So the other angle will be pi minus pi over 3 or 2 pi over 3. So those would be your answers. Does that make sense, Sabrina?
Yeah.
All right, who else? Who else, Finley?
We do 3D.
3D. Now this one, they give me the angle and they want the tangent. So we're finding the tangent of negative 2 pi over 3. Now, Finley, this is completely up to you. If it's easier for you to think about that as a degree measure, you can change that into a degree. We know pi is 180. 2 of them is 360 divided by 3, so that's what, 120? So the tangent of negative 120 degrees. You do not have to do that. You do not have to do that. But if it makes it easier for you, go ahead. All right, negative 120. Where is negative 120? Right here? So how big is my reference angle then? 60. And again, you either have your unit circle memorized or you know these sides. The only thing is, we're not in quadrant 1. So something's negative in there, right? Please don't forget the negatives. In this case, it doesn't matter because we're doing tangent. So I got root 3 over 1 for root 3 as my tangent. Does that make sense to you?
Yeah.
Okay, as always, lots of ways to do the problem. Don't anybody get confused. Make sure you get root 3 as your answer. You're all good. All right, who else? Who else? Well, okay. All right, so here we're going to write the equation. Wait, I missed something. This is negative pi over 6. This is 3 pi over 12. 8 pi over 12. 13 pi over 12. All right, and we start right here. All right, and you're going to write the equation of a sine and a cosine. So keeping in mind that there are really 4 adjustments that we can make to our equations. We're going to figure out what all those empty ones are. So Peter, when you looked at this, did you think of it as a sine or a cosine? How did you start with it? Thought it was a sine. So did you start right here? Okay. So I'm going to do that in color so we can see. So when Peter looked at it, he thought of it like this. That's what he thought. So that actually would be a negative sign. Right, Peter?
Mm-hmm.
And its amplitude is a half. Now, it looks like it's oscillating between a half and negative a half, so I don't think we have a vertical shift. Would you agree with that? And since you chose to start looking here, and you can look wherever you want, but you chose here, your phase shift is 3/12 or 1/4.
Yeah.
Now remember, this number impacts the period. What is the period of your picture? It's going from 3/12 to 23/12. So what is that period? 20/12. Yep. Now, given the equation, we find period by taking 2 pi and dividing it by that number. So 2 pi divided by that number has to be 20/12. So let's cross multiply here. So 20 pi n equals 24 pi. So did you get, what is that? 12, 10, 6/5? Did you get 6/5? Anybody else get that? Now, the good news is, once we've struggled through all that, writing the cosine equation is going to be a cinch, because none of the numbers are going to change except this one. There's no vertical shift. The period is what the period is. The amplitude is what the amplitude is. Now, when you're looking at this as a cosine, where are you starting your looking? Right here? I would start right there and look at this piece right here. Now that's a positive cosine, and the phase shift is negative pi over 6. Hey guys, we gotta really be zeroing in on this stuff. We only have a couple sections to go and it'll be test day. All right, so who else? Who else found something that we need to look at, Leah? 11. So there's the period, all the stuff, and sketch it. Okay, so let's refresh our memories here. What does a tangent even look like? We got sine and cosine there, but what does a tangent even look like? Asymptote at negative pi over 2 and positive pi over 2, and then a squiggly like that. Okay, so that's what I'm starting with, and I'm going to make all these changes to it. Who remembers what I need to do first? Factor out the 2. You don't get rid of it, you have to keep it, but we want to get it out of that parentheses. So dividing by 2, multiplying by a half. There we go. Okay? Now, this right here is your phase shift. So this tells me that whatever used to happen at the origin now happens at negative pi over 8. So what used to happen at the origin? You had a 0, right? So now that 0 is at negative pi over 8. And we got an asymptote, and an asymptote, and a negative tangent. So it's upside down. Now, normally, the period of the tangent and the cotangent is what? What is this distance normally? Pi. This time, our period is going to be pi divided by 2. Remember, with sines and cosines, you do 2 pi because that's their standard period. Tangent is pi. That's your starting period. So the distance between the asymptotes is pi over 2. Can we reason out, logic out, an easy way to find these asymptotes? Add pi over 4 both ways, right? So pi over 4, would this be 1/8 and 3/8? Check my arithmetic. Is that right? Now, the 5, and I apologize to those of you coming from another class, I pretty much ignore that 5. I know in my heart it makes the curve steeper, but with my kind of sketching, that's really hard to tell. So the negative's important. I'm really not paying attention. What's the amplitude? No amplitude. Period was pi over 2. Frequency is 2 over pi. Remember the reciprocals. Phase shift or horizontal shift is negative pi over 8. And vertical shift is 0. We didn't lift it up at all. Lucy?
Can you do 7D?
All right, we good here? I can't remember who asked that. Which one? Lucy.
7D.
Which one? 7D. I need a calculator for this problem. And I need to be set in radians. All right, Lucy, what does this tell me right here? Whole circle. So I'm going to get an answer anywhere around the circle where the sign is a positive number. So where is that? Where is sine positive? Look at me, people. Sine is y. You got to remember that. Sine is y. If y is positive, sine is positive. So I need sine to be positive, so I have to be here. That's it. Those are the only 2 places. Now, second sine 0.31. Make sure you're in radians. Second sine 0.31. I got 0.315. I'm just randomly rounding. Is that what you got? Now your answers, remember, are the angles in standard position. So one of the angles is 0.315. What's the other one? How will you find the other one? Pi minus 0.315. Which is 2.826.
Make a difference that one of them is greater or equal to and the other isn't?
No. Keep in mind, Sabrina, that it's one of those technicalities. Keep in mind that 0 and 2 pi are really the same location, right? So if 0 is an answer, then so will 2 pi automatically be an answer. So generally we don't include both, but it doesn't change the way you do anything. All right, who else? That's it? Do we know how to do everything else? All right, if you haven't done that sheet yet, you need to get it done. I am going to post the answers, but you need to get that done, okay? I'm also, since you're all here, going to hand out some review work. We're not ready for this yet, but you'll have your review sheets then for this after we do the last two.
Yeah, I just don't know if they'll let us.
No, they'll let us, and they were like, are you sure it's not intelligent? I was like, they don't care.
No, colleges don't want to learn. You learn nothing.
Like, none of my brothers ever took physics class, and they're fine. All the
We can write out extraneous.
also, like, it'll still show us the speed for the first time. Our eggs. Yeah, like,
All right, chatty Catchies. No, we're not on that now. We're getting our notes out. We got to talk a little bit about 4-7 today. Our inverse functions. Now, we don't have time to do this and everything. But I'd like you to really get a sense for what these inverse functions mean. So, I'm going to go ahead and just sketch one period of my basic sine function. Just my regular old sine function. You know what this is. It should be a half. You've done this a million times. Here it is. Now, I am going to sketch the inverse. Okay? Now, we can write that a couple of different ways. This is kind of the old-fashioned notation. Means the same as this. This is your inverse notation. This literally says y is the angle whose sine is. So the inverses, you're always looking for the angle. You're going to find the angle. Now, I want to draw a picture of this. Who remembers how we can get the inverse from the original? Who remembers what we do? Switch x and y. So the point 0, 0 isn't going to change. But this point is pi over 2 comma 1. So now I'm going to plot 1 comma pi over 2. Remember, the ordered pairs flip-flop. So this ordered pair right here is pi over 2 comma 1. So I plotted 1 comma pi over 2. What about this one? What ordered pair is that? Right there where my finger is. Pi comma 0. So I will plot 0 comma pi. What about this one? What's this one? 3 pi over 2, negative 1. So it'll be negative 1, 3 pi over 2. And finally, what about this guy? He's 2 pi 0, so he'll be 0, 2 pi. Now when I connect these dots, did I get a shape? Did I get a shape that makes sense to you at all? Yep. Because when we do inverses, we switch the variables. The original sine curve oscillates across the x-axis, so its inverse is going to oscillate across the y-axis. Makes perfectly good sense. However, there is a huge issue with that picture. It's right, but can anybody tell me what I don't like about that picture? George? It's not a function. It's not a function. That is trouble in River City, folks. We do not like things that are not functions. What?
Is that the notation that it'll be written like y equals arc sine x equals?
Well, no. Use one or the other. These are
okay.
both notations for the same thing.
Okay.
Now, in order to make this a function, some really smart guys back in the day said, I'm going to go ahead and continue this picture a little bit more. Some really smart guys said, okay, I can't look at the entire inverse sine picture. I can only look at a chunk of it. And they chose to look at this chunk of the picture. Now we'll talk about that in a second. But if we only look at that part of the picture, is that a function? Yeah. Yes. Where the inverse sine is concerned, we have what are called, well, all the inverse functions, but for sine, we have what are called the principal values. And the principal values are from negative pi over 2 to pi over 2. In other words, every time you do inverse sine on your calculator, it is going to give you a number between negative 90 and positive 90 in degrees. Every time. Take your calculator out. Type this in. What happens when you type in a positive number? What happens? Between 0 and 90 or 0 and 1.57? And what happened here when you type this one in? You got a negative one, right? You got this piece down here. That's going to happen every time you do an inverse sine. Now, what does this have to do with you? Because your calculator knows the rules. If you give in an inverse sine problem, it is automatically going to give you an answer here. Automatically. If you're doing a problem by hand, though, you have got to remember this. That the inverse sine only exists in quadrants 1 and 4. In other words, when you look at your whole circle, you only look over here. Quadrants 1 and 4. You're never going to get an inverse sine problem that's written this way in function notation. You're never going to get one over here. So you got to remember that. You have to remember that. Now, we can do the same exact thing with the cosine. We'll do it real quick. So what would the inverse cosine look like? Well, instead of 0, 1, it's going to be 1, 0. And pi over 2, 0 will be 0 pi over 2. pi negative 1 is negative 1 pi. So here's your inverse cosine. Nothing magic there, I just flipped everything. Here's where things get wonky. If I continued this picture, and I apologize, those in the back maybe can't see it. If I continued this picture, is this the section I want to look at? The same section I did over there, negative pi over 2 to pi over 2? Will that work for me? No, because that's not a function, right? So with the cosine, we don't look at that part, we look at this part. So the principal values for the inverse cosine are quadrants 1 and 2, 0 to pi. 0 to pi. Every answer to every inverse cosine problem will be 0 to pi if we're talking about the function, if it's written this way. Lucy?
What does the point on the x-axis say?
That's 1 comma 0.
Okay.
It used to be 0 comma 1. Principal values for sine, negative 90 to 90. Principal values for cosine, 0 to 180. What about tangent? The principal values for the tangent are the same as for the sine. The principal values for the tangent are the same as for the sine. So if someone says to you, do this problem without a calculator, this notation tells you that you have to be a function. It's a tangent, so it has to be 1 or 4. Since it's negative, it has to be 4. Did you follow my thought process as I was going through that? And then we know the tangent's 1. This angle's got to be 45 degrees. Or pi over 4 radians. But when you answer it, keep in mind, it has to be in this interval. So don't say 315. Don't say 315. You have to say negative 45. Kids, it's confusing as heck. You have to know the rules and you have to follow the rules. Your calculator will do it automatically. So if it's a calculator situation, you don't even need to stress it out. It will do it automatically. But if you're doing it by hand, you have to think about the principal values. All right, so quickly, I gotta get the other ones up here. So we're talking about inverse functions. We'll do some problems tomorrow. We just got the rules down today. So quadrants 1 and 4, that is negative pi over 2 to pi over 2. These are the inverse sine, the inverse tangent, and the inverse cosecant. So any inverse that's sine, tangent, or cosecant, you are going to answer between negative 90 and 90. Any of the rest of them are going to be in quadrants 1 and 2. Lucy.
Okay, this is actually a really dumb question, but isn't it like the inverse of cosecant? Is that not sine?
No, the reciprocal of cosecant But the reciprocal is not the inverse of the function. Now, because they're reciprocals, Lucy, they have this connection right here for sure. But no, this is not cosine. Okay, this means inverse sine. So we got 3 functions defined in 1 and 4, and 3 functions defined in 1 and 2. So let's see if we have time to do one quick problem. Number 4, evaluate exactly, no calculator, answer in radians. No calculator, evaluate exactly, answer in radians. All right, so here we go. Come on, focus, got 2 minutes, I think. Yep. All right. Inverse sine. What quadrants are my options? My quadrants are 1 and 4. This is a positive number. So therefore, it has to be quadrant 1. The sine is √3/2, which means the reference angle is how big? 60, which in radians is 1/3 of 180, so 1/3 of pi. And that, my friends, is the answer to the problem. That's it. That's it. All right, let's stop there. We will pick up here tomorrow. We'll do some more of these. Please make sure you finish the 4146 recap, people.